we go 1, 2, 3, 4. Okay, so it goes S. You want me to do a particular method? No, that's fine. Bus driver, you are holding the steering wheel because that's where the 4 is. So the bus driver is on the other side of the screen from you. And you go 1, 2, 3. From your perspective, it looks like you're turning right. But from the bus driver's perspective, she or he would be turning left. Okay? Try the next one. This is 1, this is 4. Where's 2 and 3? These are the same group. This is achiral. I just drew it for fun. There's no RS there. It's not chiral. There's not 4 different groups. Next. Let's do the OH group. This has 2 stereoisomers. 1, 2, 3, and 4. So this is S. Is that what we got? And the other one I'll do in brown. There's an H here. That's 4. So we go 1, 2, 3, 4, R. Any of those you want me to do? Yes. The carbons where are on the ring. So are you talking about this stereocenter, the top one or the bottom? Bottom. You got these 2 carbons. They're both carbons, that's right. But this carbon's connected to 1 carbon. This connected to 1 carbon. They tie again. This carbon's connected to 1, and this one's connected to 2. So this chain, because of this branch, beats out this branch. Try it again. These 2 are tied, they're both carbons. These 2 are tied, they're both carbons. But the carbon on the left is bonded to 1 other carbon. The carbon on the right is a tertiary, bonded to 2 other carbons here. This one beats it out as a 2 priority. Any other questions? Yes?
Just to make sure, so the first one, reason why that
The top one. Yeah.
and the one on the left is 3 because it's 3 hydrogen compared to the second one and a few hydrogen.
Correct. To restate that, this is 3 because it's attached to no other carbon. This is 2 because it's attached to 1 other carbon. Takes priority. Yes? You can do the bottom one. Oh well, if this is on a test, it's in a table, which is a typical way to see it. Then for the top one, in the box, you just write S. So, like this would be R or S, I don't know which one, because it doesn't give you the dashes and letters. Okay, let's start with the easy one. What's this? Amine has a nitrogen in it. Okay, let's go to a fun one now. This one. Ketone on this side, and on this side is the ether. Make sure you don't put ester. The oxygen would need to be here or here to be an ester, one of these 2 locations. Okay, let's go to the next fun one, this. I hope you didn't put carboxylic acid because the OH needs to be directly bonded to the carbonyl. So it is what? This is a ketone, and this is alcohol. Fun one. Better to see fun ones now than on the exam, right? Okay. What did you say here? Arene? I hope you didn't say arene because I need a double bond right there to make that happen. It is an alkene in multiple places. And Yeah, this is the alkyl or organic halide. And this one down here, ester, you have an O directly bonded to the carbon. And so that's this. Here's the alkyl halide. We've got a lot of alkene action going on. Any questions? First you? Correct. Which one are you talking about? The alcohol, I don't have an arene. An arene has alternating single and double bonds. Examples of arenes would be this. That's an arene. Or this. That's an arene, etc. Question? Was there another question? Yes.
Is there an ether on the fourth one that you drew?
On the fourth one, here.
Yeah, you see how there's the oxygen and then there's a carbon on either side of it?
That's true. There's a carbon here and here, but this is a carbonyl, making it now carbonyl derivative. If you look on your functional group table. And thus, that's how it's functions.
I see.
When the OH, or when the O is directly bonded to the carbonyl, it now becomes a carbonyl derivative and it functions accordingly. Let me show you a picture of, I don't know if I, so it would be in this category. Hydrocarbon derivatives with CO group ester. When you see double bonds, likely addition unless it's a combustion reaction. Combustion is always easiest to find, it's the middle one. So let's do the additions first. Here you just add an H and Br across the double bond. I don't have to draw the H if I don't want to. Because the molecule is symmetric, the Br can go on the other side. Next, and then same for this one, got a pentane, got adding a Br to both sides of the double bond. Okay, so those are additions. I have one free radical halogenation. I recognize that because it's Cl2, or it could be a Br2, and light. So it's going to go on primary, secondary, or tertiary? Boom, right there, done. I've got a combustion. I've got to work backwards to get the reactant. So any of these, I could have you either fill in the reactants or the products. The only one to balance would be the combustion if you have one. There's 2 C's and there's 6 H's. So it's ethane. Finally, I have this one. This one's called a what? Substitution. I don't care about the sodium, just OH minus. And it literally substitutes. Any questions on any of these? Yes? For combustion, what if you put a 2 and it was CH3? CH3 is not a stable carbon because there's not 4 hydrogens on a carbon. And also, usually I set these up so that there's 1 mole of the reactant. Yes. Okay. Next. Oh, yes.
For the second one?
Second one. Great. Do we need to balance the second one? No. Neither the first, the second, third, or fourth, or fifth. You don't need to balance. Whenever you see write a reagent over the arrow, that means I care less about balancing. And that will generally be true when you take Chem. Typically not going to balance it. There might be a few scenarios, and that would depend on your instructor. Oh, there's another question? Do I need both of the BRs in the fourth reaction? Is that the question? Yes. Because I need to add 2 entities. In the top one, I added an H and a BR. In the fourth one, I added a BR and a BR. So there's always 2 things to add across the double bond. Oh, yes. For the fourth one, Is it cis or trans? It does do something, but that something is outside the scope of our class. You will learn that in OChem. But as far as here, just draw it with lines flat, not dashes and wedges. Yeah, but all of these, the ones that are involving double bonds, there's a lot of rules determining whether it goes cis or trans and where they go exactly. That's just too much for us. Yeah, so just know it adds. Yes? Why is there only one Cl? Well, there's another product that would be an HCl. So there's other products, that's where the H goes. There's a whole series of mechanisms involving free radicals and also beyond our scope. But basically, the H that was there is gone. You'll notice there was an H here that was undrawn. That goes with the second Cl. And you won't have to write that one. Yes? Combustion? Yes. Is there a scenario where that ethane could have had an oxygen? Yes, and that should be obvious from the balance. Hopefully. There was one, I think, on a practice exam like that. Yes?
On the practice exam, there was a problem like that where it said heat, something to do with heat.
Which one?
It's like,
This one?
no, it wasn't.
This one. Yeah, some of these involve heat, and sometimes you'll see me write. These have other reagents and catalysts and stuff. This has CCl4, we're not doing that. This one can have a solvent too. Sometimes this could often have heat. A lot of these things will have other reagents that I'm not having you remember. I could write it on the test, but it's neither here nor there. Okay. C4H8. Huh? That makes it a lot harder. Okay. I don't know. This might have too many answers to possibly solve in our class, but we'll see. Okay, what's the degree of unsaturation? 1. Yeah, and I'll have to go ahead and solve this just together because we're at lack of time, okay? So, 1 degree of unsaturation. That means there's a double bond or a ring. I'll just put a circle of a ring. Okay, so let's go along this chain first. It could be something like this, where the double bond's with the O. It could be something like this, where the double bond with the O is one of the other carbons. It could be, oh my God, there are so many answers here. OH, where the double bond is there. Oh gosh, this is too hard. It could be an OH where the double bond is there. It could be an OH where the double bond is here. You and your friends can find all the ones I missed. It could be kind of an ether-like entity. 1, 2, 3, it's like that. There's a double bond. There's a double bond. Oh my gosh, this is hard. This is crazy hard. Wow, okay, I'm just warming up. Just warming up. Okay. So those are all the 4 in a row, kind of straight chain. There could be more. Oh yeah, there's a lot more. It could have an OH here, and then the double bond there. This is crazy. This is crazy. I haven't even got to the rings. Okay. It could have. So look at something like this. Double bond here, OH here. Oh my gosh, what else could it be? It could be like this. It could be like this. All kinds in that sort of configuration. There could be more. That's why I put it right now. And there would be not quite double this of rings. So if you want to stay for office hours, we can finish the problem. But this is, it gets you warmed up. Yes? And then I could ask you to make it just brutal, crushing your souls. To do all cis trans and then stereoisomers. Yeah. I wouldn't do that on the final, I'm just saying. Back to the habits, yeah. Now on the final, not with this number. On the final, if there was, say, less answers, say 10 answers, then I would happily have you draw the cis-trans RS. But this has too many to put on a final. If anything, I would say draw, 7 of them or something. And then draw one of the cis-trans and one of the RS. Something like that. For the first one, I got 2,3-dibromo 4-methylpentane. I think that's the lowest number in the set. Second one is a cyclohexane. It's, tribromo. It's dimethyl. 1, 2, 3, 4. 1, 2, and 3, 4. Take the last one, cyclohexane, so it's 1, 1, 2. Tribromo 3, 4 dimethyl cyclohexane. I think that's the lowest set. Question, yeah?
Does the prefix count when you do
The prefix does not count in the alphabetical. Some slight exceptions, you learn 2 special groups, isopropyl and T-butyl. The isopropyl is the I. I think that's the only one like that that counts the first letter. There's some others. T-butyl is one example of others that are kind of similar to it. It actually counts the B. The B of T-butyl.